D'avoir fait le déplacement ici jusqu'à Toulouse, donc j'essaie de te recevoir. Donc je vais te laisser la parole pour que tu nous montres tout ce qui se fait dans ton label à Amsterdam. Merci.
Hello everybody. First of all, thank you Nicholas very much for bringing me here. It's a pleasure to show you some things we do in Amsterdam. So to start with, we are actually very fortunate that the Fablab Amsterdam is in this building, at the first floor there with the windows. And that's the second oldest building of the city. It used to be a city port, and then we had various functions, but it was also a guild house. There were always guilds in the Waag, and that's why I wrote Where Medieval Meets Digital, because I think we are the digital guild. So as you can see here, it's totally in the center of the city. It's a 5 minutes walk from Central Station, and what can I say? I think it really helps if a Fab Lab is centralized in a city. I think it's a good thing to do. But the Waag Society, which is actually the host of the Fab Lab Amsterdam, is there at the Eijhaven, that's only 2 kilometers in this building, which is another monument of the city. It's an old warehouse. So, and this is a little bit how it looks from inside. That has been this Thursday, actually 2 days ago, where we had some ministers of justice. They came to tinker with us. I thought that was pretty cool. And a while ago, I found this one. So this is how the Fab Lab looked 300 years ago. It's exactly the same space. It's 1700 something. And, well, we are now 5 years old, as you can see. And it went actually really quick, because in 2007 I had no clue what a laser cutter actually is. Although I have a good background in metal machining and so on. So we learned, I did the Fab Academy in 2008, together with Thomas as the first remote ops from MIT. And that was, I guess, the hardest course I've ever done in my life. And a little bit about the Waag Society. We are an institute for art, science and technology. We have always been established in 1994. And we actually cover a wide range of projects, what we do in various fields like education, care, art, sustainability, public domain, locative media, and so on. And I think we are like constantly about 40 projects going on, so I don't even know some of them. But of course I'm here to show you what we do at the Fab Lab Amsterdam. So as Neil yesterday showed you briefly this thing, I thought I'll recap on it and show you, because the thing is that there's a lot of prototyping going on in all the Fab Labs around the world, and I think that's fantastic. But I made it a sort of my sport, that what I want to do is show people that you can actually do real projects. That doesn't look like a prototype, but it's a product. And that when you look at it, you don't necessarily associate it with a Fab Lab. I think it's something I like. And this foosball table, I designed 2 years ago and made it together with 2 students, was a project that I was thinking about foosball table because we changed the location and I didn't have one anymore. And I found it sad, because I think it's such a nice social thing, that if you're programming for hours and it's never working, you take a break, play some foosball, and then we got the solution. So, but mainly we made this because I noticed that actually if you make such a thing, you go through all the processes that you can do in a Fab Lab, like molding and casting, laser cutting, 3D milling, 2D milling, everything, electronics, because it has an automatic counter, and so on. So I'll show you a little movie that you can see a little bit how the process went and so on. This whole concept of a soccer table
further, make it really our own thing, and very importantly, make it open source. Learning project, since you go through all kinds of digital fabrication methods.
With the camera in it, we got electronic scoring system, we got sensors, so everything is interactive and automatic. Something more sexy, you know, like something that is nicer to see than just LEDs.
This has to be the best documented project we have ever done so far.
Actually, Angelo, who made this documentary, we actually made a whole movie of 25 minutes, which we will bring out at some point. So that was 2 years ago, and then 1 year ago, I needed a new challenge. So I thought, I was just simply asking myself the question, is it possible to make a high quality electric bass guitar using the methodology of Fablab or not? Because I'm a musician and I like instruments, and I think the award, if you make an instrument yourself and then you play it the first time, is unforgettable. But what I really enjoyed the most of this whole project was the way it came along, because it's not my bass guitar, well, it's my design, but we altered it, and it's a collaborative design. Because if you look at this was a student from the Design Academy in Eindhoven. He just came to the lab on an open day and was milling these wood structures on the Schaub. And I thought, well, wow, it looks amazing. So I just simply asked him, would you like to put this structure there around my bass guitar and do so we have a textured bass guitar? I've never seen it before. And he said yes. So he was working like for a week, I think, in Rhino to do all these textures around. It was very complicated. And then, so here is the 3D job. It's probably the most sophisticated job we've ever done on the shop board, because it takes ages, to be honest. I mean, the surface finishing on the front, as you can see it here, was like 19.5 hours. So it made me even that I had to sleep in the Fablab, because you cannot leave the shop alone, of course. But we made it, so this is about, I think, 40 hours of milling for the entire body on a flip part setup. So you take the symmetry with the two holes there, so you can turn it around, you have the same axis, and so you can, with this principle, you can build anything you want, actually. But then, again, a lot of work, gluing the neck in and so on, then sanding, oiling in, and then, like half a year later, finally, it was assembly time. But it was also that, you know, I'm not a luthier, so, and it's not that easy, so that made me, that first I wrote, I was reading 2 books about it, and the bass on top is my own bass I have since many years, so I always could a bit look how it's done in a professional way, try to imitate it. And yes, of course, I did a huge mistake. I had way too much action with with the springs. So this was actually a pretty scary moment because the base was completely done and I had to go back to the shortboat and mill out the pocket for the bridge again. And then you can't screw it, of course, after like 100 hours of work. But it worked, so this was a visitor, you know, sometimes visitors come and they like it and then I leave them to play. And a little detail I liked a lot was that you can see there this black thing on the neck with the screw. This is actually the only part which we made on a 3D printer, just for a tryout, but I was amazed that it actually can hold the strength because it's tons of kilos pulling down the strings actually. And of course, I have to show you how it sounds, a short sample where I presented the bass to my colleagues of the Waag. So that was the bass guitar. A completely different project which actually blowed my mind, I have to say, was this project which we called Hypermod. We are not so architecture based, but we were liking to do some experiments with that. So this was an attempt to combine very old traditional techniques of building with digital fabrication, simple as that. So what you see here is like the first prototype we did. So that's simple profile milling, the cheapest wood you can get. And then, so you see that here. We made about 6 of these. But then here you can see that you put this kind of bust around it, you tack it on, and then you take a mud device where you can spray mud on it. And then it looks like this. So you can make basically any structure you want. And okay, here the water or the weather will wash it down, but if you combine it with other composites, you could make a house like this. And it's actually, since we did that, I was thinking that one day I will build a house with a shop or two. But that was really a good experience. And another thing which I really liked that was happening was that we were able to create a sister lab in Indonesia, in Yogyakarta. There was a long run, I had some friends there, and I always thought they were really amazing, innovative, and so on in new media, bringing new media to Java. And once in 2008 or 2009, yeah, I was giving a class there about Fablab, or an introduction, and they really liked it. And then I said to them, well, if you can come up with concepts, why would you need one, and what kind of business cases you could do, I will try my best in the Netherlands to try to get funding for it. And 2 years later, we made it. So now we have a sister lab there, and they're doing well. Actually, I have a little movie of a contest they did this year. I really like this project because I mean they're pretty young. They started last year in July. We had the grand opening, and it's of course it's not that if you put the Fab Lab somewhere in a city that everybody is going there and make stuff. So you have to do events and stuff to attract the people that they actually understand what you can do there and so on. And one of these attempts was this project where they made these etalages, these windows in the shops, which I found was a clever strategy also, together with Lee Cooper of course. But then in the main street of Yogyakarta, you could see things they have built in the Fab Lab. And it was a competition as well. So. But maybe the most, for me, for myself, the most promising project is this one, the low-cost Prosthesis, which was initially their idea of a small business case, because well, there's many aspects, but maybe the most important is that people are eating a lot of sugar there, so you have a lot of, what's it called again? Diabetes, yeah, so then that makes a lot of amputation around here, not above knee, but mostly below knee. And the other thing is that the production in these rehabilitation centers and so on, I was there and we have looked at it, it's quite slow. So that they can make a few legs in 6 weeks or something. Or maybe one leg in 2 weeks. And it's a very complicated matter, but we thought why not try to innovate that using the Fab Lab methodology so that people could come into the lab and make their own prostheses, or we make them for one. And the idea was that we could at least help 2 people a day, that they come in the morning, we make the prosthesis, and they leave the lab with the prosthesis in the afternoon. But of course it's a very technical, difficult project. And I mean, you have to compare it with the Western, a standard Western prosthesis here is about 3,700 euros. We can pay that because we have insurance and everything, but in Yogyakarta, insurance, forget it. So, but maybe even one step further is that even in the Western world, every user who has a prosthesis is completely dependent on orthopedics. So if you have anything that makes you pain and so on, you go to see a doctor. And there actually we want to turn this around, that instead of being dependent by orthopedics, we think that if you are the user and you wear that thing 24/7, you are the specialist. So we wanted to make a low-cost prosthesis, but it should be also adjustable. Like a bike. If you buy a bicycle, what's the first thing you do? You adjust the saddle to your height, so you can bike nicely. And you could apply actually the same on prosthesis. And don't forget, like for instance, every prosthesis in the world is always made for one shoe. So if you, for instance, a girl wants to go to the disco in the evening and has a high heel, it needs actually another prosthesis. So there's many prosthesis users who have 5, 6 legs. It's totally normal. But then we think, why not having an adjustable heel, so you could actually just adjust it yourself. So that is the approach, and we're working on that since about 2 years. It's very complicated. Here you see a little attempt where I was machining bamboo, which is actually, it's very easy. The whole country is full of bamboo, so no cost at all. And but it yet has to be more thoroughly tested, and maybe I need to reinforce it with another material. But then there's several other connectors here, which we still have to figure out how we are going to do it for below $50. Here we made a little installation in our lab in Amsterdam, so I can always explain to people what this project is all about. And then, but even better is this thing. Actually, I showed this photo on the Fab8 conference in Wellington, and it got really quiet. And people came to me after and said, Alex, I didn't know you have prosthesis. But don't worry, it's still me. I'm fine. So this thing is a so-called knee walker that a professor for movement science has developed in Groningen, in the Netherlands. And it's simply a device that lets you experience how it would be to walk with a prosthesis. And I've done this on an event we had there for a whole evening from like 8 o'clock until 2 o'clock in the morning. And there was really a queue. People really wanted to experience that. I found it unbelievable. And also, like the differences between people. Some of the people, they could almost walk right away. Others, you could really see they don't trust the leg yet, so you have to learn. I mean, everybody who has a prosthesis needs to learn to walk again, of course. But so, right now we are actually rebuilding, making a second one of that, but using local material from Jakarta, because we want to use it for two things. One, of course, we want to be able to let the people experience it, but on the other side, we can test our own prototype. So if we make, for instance, a new feet design, which you can see, two versions of it to the right, we can try it ourselves first, instead of bother the prosthetic users. So, this is like 1 month ago in Indonesia. I've been there with my good friend and open source designer Jens TV, and together we made this new approach of a feet, which looks promising, I think, because it's actually just a piece of wood, and then we mill out two parts which are loosely connected here with this pin, but not fully, so it's about a play of, say, 3-4 millimeters, and then we cast polyurethane inside and fill it up, and that makes actually a joint which is much better than just a normal feet. So you see, if you apply pressure. Now the next step would be that if we make here some pockets, which you could fill with aluminium tubes or something else, so you could actually adjust the strength of it. Because also it has been scientifically proven that your roll-off curve of walking is actually changing according to different surfaces. And of course here everything is paved in Europe, but there's not so much pavement, so it actually makes sense to have different variations of it. Again, self-adjustable. And then the other thing we were researching, I'm doing that actually right now, is natural fibers. So the people from my friends from Georgia, they brought me this, and this is actually, well, you don't see it so well, but on the left side we have coconut fiber, and then the white one is pineapple, and on the right one it's banana basket. And I was trying to use that fiber and combine it with polyurethane again to try to make a new composite. And it's actually quite promising. I mean, it has to be tested yet again. So actually we took the fiber and we pushed them away so they get very fine, and then we mixed it up with polyurethane. And this is like a stone, and the nice thing is that I couldn't even have imagined before, is that actually if you blow through it, there is no, I mean, the air can go through, so there is a possibility that it can breathe, which would be great, because I mean it's mostly 35 degrees in Indonesia. So you could maybe less sweating and you have a better holding, because this is still the most important part of the prosthesis. If that is not spot on your leg, you cannot walk. And well, I would hope that within a year or so that we can pull it out and really empower people again, because there's really a lot of people, I've seen them and I've spoke to them, that they don't have, they are amputated, they don't have a leg, because they have no money to pay it. And the sad thing that happens then is that they stay home and they get completely alienated because they cannot go even to the market and buy their fruits or whatever. Okay, so now something completely different again. That was a fun project from actually 2 students I had in the lab. The cadaveric skis. I think I don't need to explain that here, but still the idea is that you fold the paper, an A4, in 3 parts, I give it to you and you draw a head, and then I fold it and I give it to the next person, but he doesn't see the head, but he has to draw a body, and then he fold it again, and the third one has to do the legs, and nobody is knowing what the other has done. So this is one we made ourselves, Kenny, Deon and me. And they took this concept further and made actually a collaborative robot, which was an ambitious project, I would say. So they had 3 months to put this thing together. They made a pre-study on the Technical University at Eindhoven, and they had a common language, which of course was Arduino. So here is how it looked. There are 5 Arduinos. The one in the head is telling the legs how they should behave. Because first, in this application, the head is looking for a light, and once he saw the light, he has to tell the legs a way to go as fast as possible there. So that was actually a thing. Here's another aspect. Actually, it could be a nice Fab Academy project as well, because the idea was that in the end, in America you make only heads, in Europe you make only torsos, and in Asia you make only legs. And because it's a common language, it can have 100 different looks. But to be honest, on the sad side, because this is now completely documented, open source, on our website since 1.5 years, and no one picked it up. That's a little sad, isn't it? But, okay. Another thing we did, which made me really happy this year, actually, because now we're 5 years there, I had a student coming in who made the Rietveld Academy, and he told me that he's actually surprised there is no printing facility in the Fab Lab. And I thought that's actually a nice idea, so we can print our affiches and everything ourselves. So we made a book, 5 years of innovation, Fablab Amsterdam, and with like 11 projects that reflect what happens, of course, but there are 11 people who have a completely different reason why they came to the Fab Lab, personal use and so on. And we printed 200 pieces on an old Riso printer, which is a silk screen matrix printer. And so you print only color by color. It took tons of time, but then we binded it as well, and it's a wonderful book. We had 200, and I had just a few here, which I gave away, but if you really want one, send me a mail. And that's it. Thank you. I guess we have a few minutes for questions as well, if you want.
One question, what you have some project for the next 5 years? I mean, you have something what is the next project
The next project?
Yeah.
Well,
big project or
well, at the moment I can make guitars and foosball tables, but now it's really time to finish this prosthesis. So I will, because I think it's the most amazing project if you can help hundreds of people with that. So I'm really concentrating now on that. And at the side, of course, I have some side art projects, but I do this for myself. But of course, there's one big goal I have, of course, is that I want to make the Fablab Amsterdam self-sustainable, which we are existing now for 5 years, it's going great, but we cannot survive as it is right now. We still depend on some fundings, you know, and I think we were really grown up, if you can say it. We can finance ourselves. So we need to create more businesses and so on, and I'm working on that as well.
Yeah. It's super nice project, but I have two questions. Well, one is a question about, maybe you can tell that you are making your house. It would be a nice story to tell you. I don't know if you have a picture or something to show. And the other one is your apartment. You're fabricating in the Fab Lab. That's a nice story, I think.
Ah, yeah.
And then, in relation with the guitar, I mean, do you really think it's worth it if it takes 19 hours of kneading and all the work? I mean, how do you see evolving? I think that we should produce musical instruments. It's something I want to do in the next years, but how do you think this could be reoriented, or how we can make new processes, materials?
It's absolutely true, you're right. I mean, it makes no sense. If I would sell this bass, I would need 5,000 euros for it, I think. So, but we did it just because of passion, actually, this texture. But it makes no sense having just the front cover of the body, like 20 hours machining. Nobody can ever pay that. But you could do an easier job, because it's funny actually, when I wrote this book, I was reading these books, is that actually, as well as in the guitar world, as in the foosball table world, there's a lot of tinkerers at home making guitars themselves, but they don't have digital fabrication machines. They all use hand machines. And that also made me actually think that I thought, well, we could do it much more precise. So you can do a high quality guitar, and I mean, we have chosen a very complicated three-dimensional body, but if you look at the Fender Telecaster or something, it's a flat piece of wood. So this we can mill in half a day, I think, completely done. So it really depends, but I would love that it would be a kind of custom business, that people would come and say, look, I want to have this guitar, and then we develop it for them. I see that happening. And to the house, I'm still dreaming how it should be, and I think I should start with a tree house first, as a study, because I'm not an architect, I have no architectural background, so I have a lot of respect for building houses. Yeah? Yeah, that's true. That's what I do, yeah, I can even show you an image of that. So, I bought a house in Amsterdam this summer. And so I made some furniture, I built the kitchen myself, and some other stuff. So this is it, more or less, 3 parts. And there was a lot of milling. It was about 12 plates. It was milling for 4 days. But I do have some images. Area assembly. So it's 3 meters 20 by 2 meters 50. What interesting was that it was the first time that I used the entire span of the shopper. So I didn't, normally it's 1 220 by 2 440, a plate of wood, but you can also buy a 250 long. But then you have like the entire span of the shopper. That was actually quite tricky. But then, now it's at home, almost done, but I don't have a photo of that. Any more questions?
Thank you, Alex, for this
Thank
presentation.
you.